Yeah, how are you?
I'm good. How are you?
Yeah, I'm good. Atul Sharma?
So I have a little bit query about Bellow.
Yeah, tell me.
How to calculate? Generally, we do NCFE for Bellow, but I want to calculate manually spring rate in coded and uncoded condition. So how can I calculate it?
Your query is manual calculation for Bellows, right?
Only for spring rate calculation for Bellow, coded and uncoded condition. Because right now we get this data from ANSYS.
Okay. Do you want to answer?
Is it manual calculation for calculate spring rate?
Anybody want to answer? Means you want manual calculation for this spring rate calculation for corroded and uncorroded.
Coded and uncoded condition.
Okay. So manual calculation again, you need some Excel sheets and that one, right?
Yeah, and differences?
Yeah, I think we didn't prepare it. Anybody have this manual calculation or anybody know in this group?
No, I have never done any expansions.
Okay. I think we also not you ANSYS you taken, but we used to do in the PVLite. In PVLite, you get the formulas and that one. You can put it into the Excel and you can try with that one.
Yeah, you can try the, I think now UHX part, no? Maybe now it is moved to division 2.
Yeah.
Yeah,
Maybe
I tried, but it is quite. I think I float a inquiry for a Bellow to vendor. They are saying that they will provide it the Monday or the Tuesday.
So Bellows and that one, it's again it's standard or part. So you can ask the vendors. They're having
I floated the
in-house
inquiry.
sheets and
They
something.
are saying that they will provide it the Monday or the Tuesday.
Yeah. Okay. Any other?
No.
Okay. Kaushik, have any?
Yes, no question from my side, but I just want to reply the last week some query from Ramakrishna, right? Regarding the Inconel, correct?
Yeah.
yes.
Okay, so Inconel, that material we used for the heat exchangers, for the tubes, it was SB622, UNSN 10276. So that was for the sea service.
UNS, what is the number you said? Sorry. Yes.
N for Nagpur, 10276.
20?
10276.
Okay, N10276. Okay.
Yeah. And for the tube sheet, it was SB462. And the UNS number is same.
Okay. But
And
but this is not popular popular material.
Yes. Not popular and say costly, very costly.
Yeah.
And for tie rod and the other, we use this SB574. UNS number is same, but it's alloy N10276. So all are the number is same, N10276.
Yeah. Actually, Inconel, there are two metals. One is LI 625 and LI 825. These two are popular, but this one, this is, I think.
Okay, maybe So why because the pressure was very high for this.
Okay.
That's why maybe this material the pressure it was the maximum allowable pressure. 1 second, what was the design? Okay, operating condition was varying from 23 to 100.
Okay.
100 bar. So that's why maybe.
Yeah. Thank you, Kaushik.
Actually, what's his question was last time I think Anshul you are not there. So his question is where means Ramakrishna is asking where this duplex and super duplex will be used and that one. So in that one, just our discussion is going on, and Kaushik said that he used some of the places in duplex in that one. So he's
No, actually, this was for Inconel.
okay.
Just actually, I searched for the duplex and super duplex. I found some. Generally, this we have 304 SS304 is generally it will be mostly based on the chloride content of the water. So based on that, it will vary. Um, for SS304, we can use up to chloride content of around 250 ppm the chloride content, and SS316 is generally used for up to 1000 ppm of the chloride, and the duplex stainless steel, that is duplex is up to, we can use up to 3600 ppm, and beyond that is generally super duplex, which is for seawater applications. This is up to 19,000 ppm. I mean, this is what I wanted. I just want to share the experience.
Oh. So it is in the seawater only the content, ppm content will
Yeah,
be depending
yeah.
on we have
Yeah,
to select it. Okay, okay.
So seawater, general super duplex is only preferred. Yeah, but Kaushik is saying they used this material in colloy also. Yeah, because this may be the case because presence of the alloying elements, chromium and nickel, etc. They will generally give the better corrosion resistance.
Yeah.
We had one duplex also. I'm not sure you have had this material. This is SA789 UNS S31803.
Yeah, 3103 is the most common. Yeah.
Yeah. So that for the
Yeah.
tube we used, and that is at the same. The project location was same. But there was like one heat exchangers. One type heat exchangers was incolon, another is duplex.
Yeah. One minute. Let me just pull my book. I have noted. 1 minute.
Anshul, you used any duplex or super duplex?
No, actually, prior to my joining the company, they have used in one of the tag duplex material, I guess, but I have not worked on duplexes. This 462 and 564 I have used in color.
In Kunala. Okay. Okay, Ramakrishna, did you note down his?
Yeah. So this. Duplex stainless steel, S31803 and S32205. These two generally used. And they are recommended up to 3600 ppm of chloride. These materials generally used for, very high corrosive service water applications.
Yeah, both the condition, it was seawater only, so that was highly corrosive.
Yeah, for seawater, definitely super duplex. So in that, two types of grades will be used. One is LI2507 and LIZ100. These are commonly used. There are other grades also. One is S32750 is one material, that is LI2507. And S32760, that is LIZ100.
What was that? The last one you told? Yes.
LIZ100.
No. The material full material specification.
I am telling the UNS number S32760.
S32760. Okay. I have not. I have not found in my in that project. I think only we use that S31803 only for all.
That is for seawater they used. S31803 also.
Yes. For tube sheet, buffel plate, tie rod, spacers, so everything for same.
Okay.
Okay. Any more? Kaushik, you don't have any issues, no? You don't want?
No, I don't have any issue.
Anyway, Atul Sharma or?
No, me neither.
Ramakrishna, you don't have anything today to discuss?
No, none.
Okay. Abhishek, do you have any more issues or anything to discuss?
No, sir. No, what I mean.
Okay, actually, did you use anywhere this super duplex and duplex material?
Yes, in the past I have used duplex stainless steel.
Because just now what Kaushik is sharing that is because the last time we discussed about the usage of this duplex and super duplex. We normally found this one will be used in the seawater service. What about yours?
Actually, we used for this fertilizer, urea grade. Urea, the fertilizer plant for
Oh,
RCF.
okay.
We had purchased this super duplex stainless steel. We used UNS 82750.
Okay. So it is for fertilizers. So
Yeah.
how much ppm and that one it contains or something?
PPM. I think
No,
what is
no.
the query?
Actually, that ppm I am referring to cooling water, chloride content in ppm. So this may be. I mean, what is the service in fertilizer?
It's it's ammonia.
Ammonia. Okay. So maybe I mean what reference I gave for the ppm is for cooling water only. So there could be. I mean, it will be used in other like what you said, ammonia, or sometimes in sulfuric acid also. I mean, different. Yeah, I think it depends on the process fluidity, and generally corrosion engineer will decide, right? Yeah.
Right, right.
Yeah.
Any material engineer there in this group?
Yeah.
Can we?
No. Yeah.
Yeah, one person recently he joined in our group. So we have to check with him. Uh, we have to request him to.
It would be great if we have material engineer, process engineer.
Yeah, material engineer recently joined. Okay. Any more? Any any more issues or any experience or anything anybody want to share here?
Let
Ramakrishna, you want
me
to share?
check if I have any. I'll just try to.
Sheikh, did you got this tube sheet layout and that one? It's cleared because last time we discussed about tube sheet layout and that.
No, till now I have not got any programmer who can do that.
Yeah, as per Atul Sharma said that it will be just a line method will be better, easy method and that one, not tube
Yeah,
layout.
that we are doing anyway.
Okay.
Means we are doing normally by manually putting all the points. So
Yeah. I found one question. So we do the. I mean, cladded metals we use, no. So what are the types of cladding and where it is used? Kind of, somebody can, where it will be. I mean, what type will be used where, like roll bonding and then explosion bonding
Explosion bonding.
and the, I think, weld overlay. So I mean, generally, what type of cladding will come? How to decide? Maybe somebody can share their experience.
Anybody in this group want to answer? Atul Sharma, you are
So
saying
for
something.
weld overlay, you have to go with weld overlay when there will be like the nozzles are there. Okay. So you have to, and then when there is you have to weld the area. So that area you have to fill it up. So that will be weld overlay. So there is no other option, I think, for that.
Actually, in our one of the project, it's completely process column. In that completely inside they made weld overlay, and even contain wherever the inside fluid is contact with that vessel inside, that completely they made the weld overlay, and including the nozzles or inside whatever the parts are like that.
No, but we can do the explosion bonding also. No, they can use.
That is for the plate. So you are buying a plate, right? So
Yes.
then you will ask. There are, I think, two types, as you said. One explosion bonding, and another one type is also there.
The roll bonding.
Yeah. So roll bonding, I think nobody is using nowadays. I am not sure. Okay. So for plate, you are going for that. But what I'm talking, WOL, so that is for the nozzles and the welding joints. Yeah, so blind flange and the flange, so that all weld overlay, because that is I mean, it's a cost-effective method.
Correct, yes.
Yeah, and for the plates, then if you go all Weldoverlay, it will be very, means the time, more
Yeah.
time will be required for it.
Yes.
Abhishek, you want to ask
so-
something? Abhishek, you raised hand. You want to ask something?
Yeah.
Yeah.
Actually, in the offshores, we have used carbon steel plates for these pressure vessels, like SA516. Over that, we have taken this Incolloy clad plates, and it is a explosion bonded plate. For the shell descents, we have taken that SA516 plus Incolloy because it is a S2S service there. In offshore, no, we have S2S gas, hydrogen sulfide gas. So for that purpose, the carbon steel plus Incolloy clad plate, we use it.
Means wherever inside completely you, with Inconel you done like that you are saying, no?
Yeah, the base is carbon, but above that there is a plate Incolloy bonded plate because the product is S2S, hydrogen sulfide. It is very costly.
So it's a plate joined or it's a welder? Means by welding they done or they just
It's not
joined?
it's not a welding. It is a special made plates
Okay.
manufactured in the
Yeah,
plate industry.
I think maybe explosion bonding.
Yeah, correct.
Just plate is
So
attached.
we did 30 cladded jobs last year.
Okay.
And we, for flatheads, we use the explosion bonding, and for other sides, we use Weldoverlay, like flange faces, nozzles, etc.
What about shells?
Cells, one job we did, if in cell inside cladding, we did Weldoverlay.
Weldoverlay
Weldoverlay.
and others?
And others, like two feet. We did explosion bonding.
Okay. Yeah, for generally flat faces, they will do the explosion bonding. And what about this? For the shell plates, any?
So we for shell, one equipment we did in last month, we did Weldoverlay, all the internal shell.
So, in any experience with, directly cladded plates, you bring it and do it? Any experience?
No, we try to roll shell with cladded, but quality person issue has raised. It is not good practice. We have to do Weldoverlay in the shell side.
Oh, okay. Actually, ready-made plates will come, no? I think they will come with bonding.
They come with volume, but we have to send it to part like the PTC for the chemical testing.
Okay. So I think what you are saying is it is preferred to go with the Weldoverlay, right?
Yeah, Weldoverlay for only shell.
Yes. Yeah, understood. Shells and nozzles anyway
Yeah.
So
Wherever
if it is a flat face like tube sheets or such things, we can get the explosion bonding.
Explosion bonding.
Yeah.
Yeah, because for Monal we also did do this.
Yeah, I also used one. For the tube sheet, the titanium we used. That is also for the seawater only. In very fast. That was explosion bonded, and the tubes are all titanium tubes.
Because I have a equipment in the last May. Shell was the SS. And all shell inside was cladded with Monal, and fluid was H2SO4.
Okay. So what is the material for the H2SO4? Monal. Okay. Monal. Any further explanation for the grade? Say only Monal.
Monal 400, I think.
Monal 400. Okay. What is this? This is a non-ferrous material?
Yes, it is non-ferrous. Section 2B.
Okay. Monal 400 you use for the H2SO4 service. Because of H2SO, because of sulfuric acid, this was used, Monal 400.
Yes, sir. For 2 tags. And tube was titanium.
Okay.
Okay. Any more?
I have one more question. Generally, what is the difference in terms of design of equipment compared to offshore and onshore?
Anybody want to
any
answer it? And
what major differences will come?
One thing is in onshore, the offshore.
Yeah.
Because of the barge, you have to analyze the vessel for transportation case. Its rest of its operation cycle. Not like a
Okay.
lifetime. It will be for rest of its cycle, and there are vertical loading too on that.
I don't know.
actually, in onshore and offshore, what we worked in that project, the placement of these vessels means if it is on the saddle, so in the barge and that one, it will be exactly the frame which designed. It should be placed on that frame only. So accordingly, only we have to place our saddles on the vessel, and then we have to analyze. So this is one condition, and also there is one more condition that they want minimum weight of each equipment. So normally they go for division 2 and division 3 analysis of even it's a lesser pressure also they will go for division 2 to know to make the weight of this equipment as very minimum.
Minimum. Okay.
Yeah, to stay that one. And also there is one more is that the placement of this equipment means as less as area it should consume to place that means more here and there you cannot make. Even if you make the nozzles you have to place in one sided, so it can be easily the piping will be attached like that. They means as minimum area, as minimum weight, as minimum as where it's available the structure your bolting should be placed like that. It is means as per our way done.
So it should be compact design.
Yeah, compact design that one you
Yeah. The first point I didn't understand. Can you explain regarding the you were saying? I didn't quite get it.
actually this barge and that one no it is made of full of structure.
Correct.
That structure no it's contents of beams channels and that connected.
Correct,
So
correct,
our
yeah.
saddle the whole the bolting of this saddles and that one it will be drilled to that channel or beams. So
okay.
that beams and your location your saddle location should be such that it should be placed on that channel or beam location.
Yeah.
So then only you can drill and you can bolt that your saddles and
Yes,
that one.
yes.
So these
Yes.
are
What happened is there is no concrete to redistribute the forces of equipment. So, like in Pivlight, you design the skirt supported vessel. There is a requirement for FC, concrete strength. In that, you have to add the steel strength. Then,
yeah their option is there. You have to select the steel. You can select the structure. You can select the concrete also.
I think there is a simplified method there. I think one is Brownell and Young method, and there is one more simplified method, steel on steel.
Yeah, steel on
option.
steel.
yeah,
Yeah,
you
steel
have
on
to
steel.
go for that.
So normally we when we are placing on the structure we go for steel on. Even in the skid type equipment also we used to do like this one steel on steel.
Yeah.
Yes. Actually, we did one project at like 4 deck level. And in each deck, there was different equipments.
Okay.
Okay.
So deck wise, they provide the loading data that how much the barge loading will be applicable on each deck, and even in each deck, they provide the certain areas like X, Y, Z axis. For up to this length, the loading will be this, and for this length, the loading will be this, and other. So generally, the skirt supported vessels are FE analyzed for offshore applications.
Okay.
Yeah.
So means different.
Actually, Anshul, you said that transportation, those accelerations and all to be taken care. What you said, some life cycle analysis to be done. You mean like a dynamic analysis?
What I meant to say by that, generally we take higher allowable strength for transportation analysis because transportation is a once in a life cycle occurrence.
Correct.
It won't happen again and again. But in case of offshore vessels, it will always be on the ship. So the barge effect will always be there.
Okay.
So, I mean, the customer asks us to do the FE analysis, not the fatigue, but FE analysis they ask for us.
Yeah. Actually, I did one, I mean, I did some vessels for an offshore project, but client didn't ask anything. At that time, maybe I was not knowing. And as a kind of.
Okay, normally there is client also provide that is we call G loading.
Yeah.
Yes.
We checked for the G loading that.
Okay, so that is, I think, normally customer provide that sway, surge and heave. So that parameters
Yes.
we have to put in X, Y and Z. So
Yeah.
I
Yes.
think
Yeah,
that should be enough.
Yeah.
If it is coming safe, I think that should be enough. Because that parameter sometimes changes after, sometimes customer give initially some conditions and then change later on,
Yeah.
and it will impact in the vessel design.
So what I see is, I mean, a guy who does the onshore, offshore can easily do the design of, I mean, onshore guy can do easily the design of onshore, offshore, very easily. Only maybe little initially, maybe he will struggle for maybe a month or so. Yeah, with these new things, right?
No,
Yeah.
the problem will come as I'm telling the experience. Okay, why this experience is required? Because he will not ask to client what is required.
Oh.
Okay, so then normally he will design it.
Mm-hmm.
Once he design, he will not consider this G loading. Then everything
Yes.
will be fine. Means all other parameters will be okay. Then customer, after confirming the transportation or whatever the ship conditions, then he will get that parameter. Then the guy he didn't ask whoever designing. Then he will get that parameter. Then he will redesign it. Then maybe the saddle may fail. So
Yeah.
these are only the difference. Otherwise, all parameters is almost same. Only the seismic design is different.
Yeah, I think Abhishek, you want to say something?
Yeah. Yeah.
As you mentioned, G loading. So G means what? Modular feasibility?
No,
What
G
is
means
G loading?
gravitational force. How much of the weight effect you have to consider in a certain direction. Like your vessel is 1 ton,
Gravitational.
and you are taking 0.2 G on the X direction. So you have to take 0.2 into your weight into 9.81 to convert it into the force. That is your G loading. You understand that, or would you like me to repeat?
Yeah, got it. But this G loading, we have to do in what case? For saddle design or for
No,
vessel design?
in every case, even if you have a stationary equipment, you have to move the equipment from your side to the customer location. Na?
It's a
So,
transportation when verification of
yeah,
transportation
transportation
load.
analysis
Yeah.
will be there. In road analysis, generally 1.5 to 2G is used.
Now in PV light,
Do
it's
you mean to say
directly you
this?
can apply
What we
this
do
zero.
CG loading? Center of gravity CG loading.
No,
Do you mean to say it is the same?
no. CG is different. CG where your equipment weight and that one comes, it gives that value. But this G loading actually it's a three movement. Means it's
Yes,
a
three directional
G,
transportation analysis.
yeah,
Okay.
which
You
occurs
consider
while
it is
transporting.
similar to seismic loading only. You can say.
Because
See,
this while
if you
transportation your vessel can tilt or it can be what your it's similar to seismic action it will takes place. That's why they applying this G loading in that one.
So we have to consider this for this transportation.
Mhm.
Okay.
Yes.
Transportation loading.
Yeah, yeah.
Assume your vessel is on a truck and the truck suddenly stops.
Mm-hmm.
So, because of that stoppage, there will be forces in that particular direction. When your truck turns in X and Y direction, so because of that turning, there will be load on this direction. When the bump is there, your vessel will move upward. So the loads will be in upward direction. So all three direction loading can happen in a road transport or any transport analysis. So that is why people generally do that. Yes.
Also,
And one more
what,
thing, I think
the formula-
generally wind loads also will be very high, I think, right? Wind speed will be high.
Yeah. Wind speed in offshore application is higher, and offshore is typically difficult for piping engineers because They have to fit every single thing in compact requirement. So it's more difficult for them than it is for us.
Yes. So I mean only these differences, these minor differences.
Yes, in our case, seismic was not applicable because only barge.
Yeah. Anyway, because
Yes.
seismic is not required because your accelerations are dominating. G loading.
Okay.
I think somebody said about the service also. I mean, I think it is somebody said in service wise. I think generally it will be more. Mostly it will be south service. Is it
Which one?
in offshore?
No, there can be other services too. No, I mean we provided for nitrogen only.
Okay.
But yes, service wise, not I have come across, but material wise, they require stringent corrosion allowance requirement because marine environment.
How much it is? How much it is?
I mean, we provided the SS vessel, so in our case, they requested 316L.
Okay. And do they consider any external corrosion allowance because the environment is corrosive? It
No,
is
there is no.
no. Okay. Okay. I think they'll do a. I think maybe.
They'll add it on the inside only.
Yeah. I think the outside painting is they'll put a. I think good quality so that
Yes.
it will not corrode. Okay.
Okay. Any more?
Yeah. To summarize.
And what does the,
Yeah.
and you used one formula some couple of minutes back for the G loading. So what was that formula? Can you repeat?
0.2 G, as I explained.
Yeah. 20% of.
I was just referencing it. It was a large requirement. For road transportation, if you assume 2G loading, when somebody said 2G, it means that 2 times your weight is being acted in that particular direction.
Yeah.
Yeah.
So do we have that option here PV light?
Yeah. PV light it's
That's the option. You will go for the transportation analysis option. It is in the top middle corner, top middle.
Yeah, in there you have to input. You need to provide G loading values of that one.
Yes.
Oh. So to summarize, in offshore, one should be aware of what type of transportation loads will come, and the design has to be compact.
Yeah.
I think these two are the major differences, and of course it will not be concrete, but it will be on steel deck.
Yeah.
I think other than this, I think there are no
Weight also.
major differences.
Yeah, weight also to be minimized. That.
Yes, and transportation analysis loading, the barge loading. Generally, client will provide it because they do the deep analysis of how much forces in each part of the ship will be acting because of the barge. So it's generally available in. You will get that in the basic engineering design data, the BEDD that comes with each project. So you just have to use that value. You don't have to calculate.
Client specifications or client inputs, you will get that one. Okay, Ramakrishna, I think you got.
Yeah, I got it. Yeah, thank you.
Okay. Any more issues?
Yeah, and I have one more. Sorry. Yeah, actually, is there a generally U type of welding? I mean, for the butt welding, when it will be used, is there any limitation of thickness? It should be something like that. I mean, after this thickness, we should go for a type U type.
Actually, it's used for higher thickness, and in our case, the planner and the welding engineer together decided with the design engineer.
Is there any reference in the code?
No.
But somebody was saying there is a reference in the code. But
It might be in the section 9, but in section 8, I don't think there is. And also, they do this because to reduce the material consumption, consumable consumption.
yeah, one reference is given in the code. That is, we can use single V up to 16 mm. That is only the reference I find.
Yes.
Yeah, so above 16 mm it has to be
Double V or
double V. But actually, in my experience, we use even for higher thicknesses also single V. Actually, I think if your WPS and PQR is qualified for, I think they can. I mean, they're free to choose. We used even for 40 mm also single V.
Yeah, it depends again. If from inside you are not able to weld or that one, then they will choose the single V and they will do that one. But if inside welding is easily accessible and they can do, then normally it will be above 16 mm they go for.
Yeah, correct. And yeah, that's right. And yeah, they have to do the root run with the TIG welding.
Yeah.
Yes. Yeah.
Okay, Abhishek, I think you raised hand. Something you want to, some more?
Yeah. And just I want to give a reference that you can refer ASME V 16.25. You will find the edge preparation and equivalent. You will find more detail in that 16.25. Okay, now my the last question is that at the start of our discussion, I asked for the solutions. So I got one solution that in order to mitigate the external loads like piping loads to equipment, you can try with the nozzle pro also. Likewise, I want to know FEA because in
Yeah,
the
you can do.
discussion,
Yeah, you can do. You can do.
with FEA, in what case we have to do? In what case we have to do FEA?
your WRC cannot be used.
No, even
Or
WRC, if your WRC fails in that one, then you have to try for FEA. And FEA, there are a new option in PVLite also. In Nozzle Pro is directly connected to PVLite. You can directly inside the PVLite you can analyze FEA.
Yeah, this actually I will answer. Actually, this nozzle pro is also FEA. It is a customized for the nozzles. FEA, you mean you want to do the analysis with the ANSYS, right? Is that your question, Abhishek?
Yes, that.
Okay. Yeah, so actually, you can get an accurate result if you do it in ANSYS, if you do it correctly. Yes, so it is your choice actually. So you can do a WRC or you can replace the WRC with the FEA because it is your choice. You can do it.
Normally, FEA we go for when WRC not fails or the satisfaction we not get the values in there. Then we'll
Yes,
go
correct,
for.
correct. But in his case, actually, it is failing. No, because of very higher loads.
So then better you go for FEA.
FEA,
Yeah.
yeah.
If it is failing and loads are higher
Yeah,
side, yeah.
but FEA analysis is generally costly compared to. I mean,
Okay, so no, normally general answer will be we will go for FEA when your thickness is coming very high as per calculation. Okay,
Correct.
so we want to reduce the thickness. So there is no manual calculation which can reduce it. So then you go with FEA and that will show the micro level material properties, and then the thickness will reduce with a proof of calculation which will be accepted by AI, and then it will be satisfied and then you can use the thickness. So you are actually reducing the cost by increasing the cost into the design. Okay, you are reducing the material cost, you are increasing the design cost. So that is the generic answer for why you do FE. So your thickness is coming very high. So anything, even the saddle also sometimes. The saddle you are coming very high thickness. So you want to reduce. How to reduce? The only way is the FE.
and you don't have to
So
develop
when
the
we
whole
look
product.
at FEA, how do we reduce the thickness in FEA? Means suppose the material is same, only thickness
Actually,
is required as per
the
the
thickness
contact we
is
have to
for
provide it.
okay.
How
So what
FEA reduces the thickness?
Okay, FEA is doing the calculation in the chunk level. So I mean to say you suppose a material we are normally doing stress by strain, right? Okay, so the FEA is applying the stress to a very micro level structure. So then you will get the stress in every layer. Okay. So sometimes you will find the all layers are passing. Only at some layer the stress is very high. Okay, so that way it will reduce the overall thickness. What my point? There, suppose a thickness is coming 100 mm in some material. What FEA is doing? FEA is doing the calculation in the middle of that part with a small, you can say the small cube, macro cube, and it will apply all the pressure or whatever conditions or boundary conditions are there. So then overall the thickness will be reduced. Okay. But in our manual calculation, that case is not considered. So that's why we cannot find. If you simple stress and strength, whatever we call the allowable stress, and we get it from the section modulus or moment, so that way the thickness will come always high.
Yeah, to add to that, I will say,
Okay.
Abhishek, see, actually what normally we're doing is called design by rules. In the design by rules, is generally the allowable stress is restricted by code, like whatever is given in the code. If you go for FEA, so generally we check for what is called allowable stress in tension. That is the majorly we check it, right? So in case of FEA, they will check the allowable stress also, and they will check the stress. Tension plus bending, like that you can go up to 1.5 times of stress. Like that, more allowable stress is allowed more in case of FEA, because you are doing the analysis accurately. So you can say you are taking more allowable stress, so that's why your thickness is reducing.
It's a conservative way it's doing.
Yes.
Means layer by layer it's analyzing, and it's
Analyzing, yes.
yeah, it's exact finding your whether
Finding,
it's failing
yes.
or it's not. But in our code,
So in the conventional analysis, since you are not doing the complete analysis, they establish the allowable stresses based on their experience. So since they are not doing the 100% analysis, they will take little bit safety factor. So to be on safer side.
okay,
Yeah.
okay,
Thanks.
you got.
And
Abhishek?
Abhishek,
Okay, yeah, Anshul, you want to say something?
yes, actually, you don't to save the cost. If you don't have to make the whole vessel. The nozzle that is failing and junction near to it, just design that and analyze that. It will if you outsource it, it won't cost more than 20,000. A single nozzle,
Okay. Fine. Anyway, thanks. I'll ask my equipment maker to be there. Go with
Otherwise,
the analysis.
Ramakrishnan sir option was insert plate was also good. If client doesn't restrict it, you can also use that.
Yeah, that is generally simplest solution. Quick.
So, just a request to.
Okay, any more? Can we wind up? Okay then. Okay, good night.
Yeah, thank you.
Okay, bye.
Okay,
Good night.
bye. Good night.